So welcome back to this week's video. In this week's video, I'm going to be looking at more containers and I'm going to be looking at the deque, the queue, and the stack. So one of the things you'll need to consider when you're implementing these classes is that what kind of data structure you will use as the underlying data structure to hold your data. It can be anything linear, which means it can be an array like this, or it can be a list, which we've seen recently. Generally, when I'm deciding which data structure I want to use, I would think about the worst case function. So in the case of an array, let's say I wanted to remove the object at the head of an array. What I would then need to do is go around and make sure I sort the array so that all the objects move back along. You can see it just takes a little while. When I get to this situation here where these are all my correct objects, I've still got one left over and I need to make sure I've deleted him as well, just to really tidy that up and implement it correctly. This isn't too bad. The main problem with this is that it could become computationally heavy when you're working with a large data structure, because you are going to have to scan that entire data structure and move things along. When you're working with the linked list, if we just throw back to what we looked at in one of the previous videos, is removing a node from a linked list at the head is really simple. It's just these 4 simple steps. It doesn't matter how big your data structure is. It's just only ever going to be no more than those 4 steps. So this is computationally a much better removal process. So this week I'm going to be looking at 5 different classes. First, it'll be the node and the linked list. This is going to be really similar to what we did the other week. It's just I'm going to make a couple of small changes to it. Then I'm going to look at implementing the container classes. And first I'm going to make a deque, and the deque is what's going to be interacting with the linked list. And then when I come to making my queue and my stack, they're just the ones that are going to be they'll be using the deque to implement their functions. I'm still working with the typedef account. We'll be changing that later, don't worry about it for now, but because I'm keeping that typedef in here, I need to also include the account.h and the account.cpp in my project file. So now I'm going to have a quick look at the changes that I made to the linked list. I haven't made too many changes. Really, it's more about what I've removed. I've removed the current pointer. I don't actually really need that. So all I've got now is adding to head, adding to tail, and then removing from head and removing from tail. When I'm removing these items, I've now changed it so that it does return a reference to the object. In the case, if I want to query the object at the head or the tail without removing the object, in that case, I'm going to use the constant function. So you can see I don't have the ampersand and I've made sure to list it as constant. This is the one that's going to go to the constant function in the node and make sure that I'm getting a copy of the object. Sorry, that happened oddly. Make sure that I'm getting a copy of the object rather than the reference to it. So the first container class I'm going to look at is going to be the deque. The deque has more functionality than the stack and the queue. The stack and the queue are actually subsets of deque, so that's why I'm going to look at the deque first. Generally, what it's going to do in my implementation, it'll hold a list of items. They're going to be able to be inserted or removed or queried from the head or the tail of the list. So it doesn't really matter. You can work with any end of the list. The standard functions in a deque, like what you would usually call them, is insert first and insert last. You'd have remove first and remove last, and then you'd have just the first and last. These are your query functions. And then I've just got a couple of extra functions, just some other query ones, the size and whether or not it is empty. If we just take a quick look at the code, you can see it's really simple. Here's my private member variable. There are those functions. There's nothing hard about those. The implementation itself is also really simple. It's all one-line functions. The linked list is actually doing all the work for us. So here you can see I'm just adding data. Here I'm just checking what that data is, and here I'm just removing the data. It's all based on that list and the properties within the list. Honestly, it couldn't be any easier than this. So taking a look at the queue, because the queue is a subset of the deque, we're going to implement it by calling on functions from the deque. So basically the queue is going to hold a deque. Queues work on the principle of being first in, first out. So that just means that if you are doing it using a list, we need to be inserting at the head and then removing from the tail and querying from the tail. The alternative is you can insert at the tail and you can remove from the head and query from the head. Doesn't matter which one of these you choose, just as long as you make sure you're working at the opposite ends of the list, because that's what's going to get you that FIFO action. The functions in a queue, what you would generally call them is you would have enqueue, that's just going to add the object to the list. You would have deque, that's the one that's going to return the reference to the object. You would have your front, that's the query one, where we're just going to return the copy of the object. And then we're just going to include size and is empty just to round it out nicely. So you can see here it's really simple. I've got my deque down here. Then all I've got is those functions that we talked about. There's enqueue, there's deque, there's front, there's size, and there's is empty. If you have a look at the implementation, it's even simpler than the deque. Basically, we're creating a new deque. We've got our destructor, which is normal. What I'm doing is I'm inserting last, and then I'm dequeuing from the front and querying at the head of the list. So now taking a look at the stack, really similar to the queue. The only real difference is that it's first in, last out. So to get that functionality, we're going to be working at the same end of the list no matter what. So you can either work at the head of the list or you can work at the tail of the list. The functions on a stack, what you would usually call them is going to be push. That's where you're putting the object onto the list. We're going to be able to pop items from the stack. We're going to be able to query, and that's using the top function, so that one's top. And then we've again just got those nice little size and is empty to round out the class. Pretty simple stuff. We're just creating a deque, and then we've got those functions push, pop, top, and size and is empty. When I'm implementing them, I just have to make sure that my push is inserting at the first, and that my pop is removing the first item, and that my top is just querying the first item. So really simple again. So far everything has been pretty easy, but now we're going to get to some slightly more complicated stuff. I'll show you my implementation of this. I'm making it so that all of these data structures can be generic. What that means is that it's no longer going to work for this account type object, it's going to work for any kind of object. So that means it should be able to work for integers, for strings, for doubles, for accounts if I want them. Basically this is now going to become generic and it should work everywhere. So it's quite easy to make the changes to the .h file. The main thing I need to do is just get rid of this type def, and then I'm going to do a template declaration at the top. Everywhere where I used to have data type, I'm just going to change it to say object instead, because that's what I've declared it as up here. Because all of the functions were implemented inside the node class, you won't need to make any changes to this. Over in LinkedList, it's going to get just a little bit more complicated. We'll still do the same changes where we declare the template here. We just get rid of that type def, and we're just going to make sure that everywhere where it said data type is going to change to object. The next differences is that when I'm declaring a node and saying that I want to use a node, I've got to be really specific about the node being able to handle any kind of object. I do that by just putting the word object in the angle brackets here, and I do it here, and that's just going to ensure that it's going to make a node for any object. The other change I've made is that I'm now including the LinkedList.cpp down here, rather than including the linked list. Before we used to include the LinkedList.h up here. Now I'm including it down here. I need to make a few more changes to the .h class, and this is probably the thing that's going to trip you up the most. So don't worry if you get errors while you're trying to compile this. You probably will get a couple. Just work through them and tidy them up one by one. The key things to remember is that before every function, you need to redeclare this template again. So you just put this line of code before every function. For any member functions, on the left-hand side where you're declaring that it is a linked list member function, all you need to do is once again redefine that it's going to be for that object type. If you're creating a new node, at the point of creation, you're also again going to need to specify that it's going to be for that object. And you can see I've got that down here as well. And I've got that everywhere where I'm creating a new kind of node. So I'll just scroll down so you can see the rest of my implementation. Okay, now I need to make those kinds of changes to the deque. This will be easier. The hardest one was going to be the linked list. So again, I define the template. I just get rid of that guy because I don't need him anymore. And then I just change data type to object wherever I am. When I declare my linked list, I make sure that it's going to be for that object type. And I'm just going to include my deque.cpp down here. Formally, what you would usually do is have an LDeque.template, but because my editor isn't showing the .template files very well, I've chosen to just use the .cpp, so that way we can still get the syntax highlighting when I'm showing you the changes. So in my CPP, I've just gotten rid of the include here, and then before every function, I've made sure I've redeclared that template. And then if I'm creating a linked list, anywhere I create it, I make sure I'm specifying that it's for a standard object. And then on the left-hand side of the semicolons, I make sure that I'm declaring that LDeque is for any generic object. And once again, for the stack, again, it's quite easy, the same thing. I just declare it here, I get rid of that, I change all those guys. I make sure my deque is generic, and then I include my CPP down here. We're getting used to it. Up here, I'm just declaring that there's a new template type before every function. I'm making sure that when I make my deque, it's going to be for that generic object type. And then everywhere I'm defining a member function for the L stack, I just also once again define that it's going to be for any type of object. Now, because that's enough changes to be making to our classes today, I'm just going to show you a main. So in this first example, I'm going to be making an integer stack. So that's quite easy. I just make my stack and I declare the type that it's going to be by putting the type inside the angle brackets, and then I just give it a name. For this one, I'm just pushing items on. You'll notice when I'm pushing items on, they're on the heap. That's because over in my stack, under push, you'll see that I want a reference to an object. Just so we don't have to do any more overloading, I've just decided to put that integer on the heap and just run with it. Then here, I'm just going to pop that guy off just to see that that has worked. For this stack, I'm going to make it for an account. To do that, I just put it in the angle brackets and say, okay, this is going to be for an account, and I'm just going to call it account stack, and then I just make it. And for this one, I just make sure that, again, I'm using the angle brackets and specifying that it's for an account here. To add items, I just push them on like normal, and in this case, I'm just pushing on a regular account. And then I'm just going to pop that account off and see how that runs. So this is it running. You can see I pushed on that 7 and then I popped that off. And then here I pushed on that account and then I popped that off. So that's the end of today's video. I've gone a bit further than the required lab task. All you really need to do for your lab task is write a queue, and the queue can use a linked list directly. It doesn't have to use a deque. If you want to implement more, you can implement something similar to mine where you do the deque, the queue, and the stack. I would also recommend maybe playing around with generics just a little bit, try and get a feel for it. They'll be coming up a lot more in the course, so it'll be good to get started on those fairly soon.